friends, today we are going to show that how to we will make Airbus A320 body with the help of OpenVSP. So here is a version of the OpenVSP. So we need to open Chrome, and with the help of Chrome we search what is the basic parameters. So I am simply search Airbus A320. Here we can see the length and wingspan and wing area and wing sweep back angle. So we are here consider the Airbus A320 dimensions. So its length, fuselage length is given 37.57 meters. The wingspan we consider with the circulates 350.8 meter. Okay, and after we consider the wing area is 122.6 square meters. The swept back wing angle, it's a 25 degree. Okay, so we'll just copy the number. Okay, and so here is a interface. We add a fuselage. Okay, so here is our fuselage. So we are not changing any other things like location and the other. So we are not add subdivision also. We are going to design and apply the length. So with the help of apply the lengths, we can see here our fuselage length, and then again view and click here right. Okay, and sorry. Okay, then after this we apply okay, close the bar, and then we apply the wing. We add the wing. Okay, so here's our wing. We just change the orientation. Okay, so we need wing span with the circulates. It's 35.8. Okay, so after we just simply copy here okay, so we adjust the location after the apply all the basic parameters. Okay, and so here we adjust the code. So our area is become okay, just check, it has become 122.6 square meters. Okay, so we just increase code and area become okay, so it's near around 122 point something. Okay, so okay, it's okay, and then we change okay, so we keep our other distance is there, then we change the section. We are only just change the tip code and the root code. So before changing this, we apply the sweep angle, which is 25 degree. Okay, and here we not apply the twist angle, and we directly apply the dihedral angle. In most of the commercial planes around 2 degree, or you can say 1.5. Okay, it's depend on capacity of the airplane, commercial airplane. Okay, then after we change the other things like root code and the tip code. So we little bit increase the tip code, but area is not the change. Okay, so after we again change the other things also, so we don't need to change the area. Okay, and other thing is okay, sorry, so the thing is we need to consider the without circulates. So what is circulates I'm showing? It's a simply wing tip area which is curved little bit. So we use the 34.10 meter, and after we add the 1 meter circulates. Okay, so again go into the plan, and we change the area. Okay, it's not more thing, so we need to consider it's little bit less, so we consider it 120. Okay, we are just creating a simple outer geometry, so we are not worried about the specific dimension because it's not available for now, and we adjust other things. Okay, then we insert the one of the section in a here we enable the symmetry with the axis of the x and z plane. Okay, so if we create any section one side, so it's automatically create other side in other wing also, like here. Okay, so just see. So insert the section, so where we need to set the sections. Okay, so here we can see this is one of the section. So here first we change the root code and tip code. Okay, so we little bit close our tip code and all. Okay, and we little bit increase the span also. Okay, and just making the real geometry only, and then we change little bit. Okay, yes, so 20 we said the sweep angle is at 20 of this last 1 meter, yes, 1 meter section. In the also now we need to dihedral angle, we need to set the dihedral angle. So just change the orientation of the complete geometry, and okay, so we just need to change like this. Okay, yeah, so okay, and here we can see like wait to little bit increase. Okay, and yeah, it's we can say it's perfect, like okay, so we don't need to change. Then we define the location, so we need to little okay, then we go in our first section of the wing. So okay, we don't need to change anything here, and we change the location from the x form. So here we need to change the location of in the x-axis, so we little bit decrease the increase the value. Okay, so you can see it's go down, so maybe it's perfect. Okay, then it's a little bit down, so we decrease the value of the z. Okay, and yeah, we can okay, little bit increase. So here I consider 0. Okay, and change the minus 0.5, and the okay, x-axis we change the with value, type the 10. Okay, it's good enough. You're right. So after close this tab also, and we see like how it's we use shaded, and also choose this fuselage and going to apply shaded. Okay, so yes, so it's little bit okay, and then now we apply the other wing also for its horizontal stabilizer. So same here we change the name of this geometry to the wing geometry to the only wing, and enter. So here is the name of the geometry change now. Okay, then we apply other wing, and we decrease and apply some of the values here. So first we need to okay, so as it is we change the location and set the location after the apply the other basic things. So going to pen, the span value I decrease a little bit, so you can directly apply the 50. Okay, and okay, then all the things you can keep as it is. Then go into section, here you change the sweep angle like this. So I'm applied 25 or 24. Okay, I'm applied 24. It's not a thing, or you can change by here also. Okay, so the root code is a 4 and the tip code is a 1 meter. Okay, so okay, maybe it's a great, and here I little bit increase the taper ratio to the Okay, maybe 0.15 is enough. Okay, and now we set the location. Here we don't apply the dihedral and the tip curve chord. Okay, so we direct the change the location from here. So okay, we adjust the location. Okay, and also a little bit down with the inner z axis. We also apply the same but 0.5. Okay, so it's good enough. Okay, so we need to apply the minus 0.4. Oh, okay, and we also change to the vertical. I am going to say with the short name. Sorry, horizontal stabilizer. Okay, and again I am going to shaded. Okay, so it's, you can see it's more than work is completed. And after this I am going to add the vertical stabilizer here. So for this I am again add the wing. Here I do one thing before changing the apply the other things. I am going to go in X form and I am disable the planar symmetry. Okay, from here. So I am just uncheck this box. So here my one side of the wing part is now hide. Okay, and then I am first here for vertical. I mean horizontal stabilizer. I am first I set my location in the fuselage first. So I need to first here I am going to apply on x rotation position 90, and here I am apply the distance for the just a minute. Okay, so it's okay little but the swept angle is here is more, so we just change the swept angle in the okay. So we not need to change any span or the chord area and other things. So going to in a section and change the swept angle here. So I am going to write 20 here also. Okay, so it's yes, so it's okay, complete. And also change the location little bit back. Okay, so I'm also here write 30 and maybe it's good enough, and shaded. I'm also this part at location 30. Okay, and maybe 31 or you can 30.5. okay, it's good. And here first we change the name to, I'm also here only write the short name vertical stabilizer. Yes, okay. So after we are apply the duct and you can change it. So here we added the duct from here. So our duct is here. So here we only just apply little bit changes. So it's look like an engine, and you know the inner Airbus A320 have the two engine in the both sides of the on the wing. So okay, first we change a little bit in the dimensions. So design in the width little bit. Okay, we are not change the width here. Just a minute. Okay, so here I am change the chord to 5 and the camber camber to the 0.05. Okay, so it's enough. So we have changed the not changed the width and height in the shape. We keep it is, and we change the chord to the 5, and the ratio is also, depth ratio is also there as it is. We only change the chord in the chamber. Okay, and then we are going to apply, and we enable this planar symmetry here for the duct. And okay, we first see the top view. So where is our location? So for top view, we only focus on the x-axis and the y-axis. In which side? Okay, so maybe it's okay. So little bit set. And okay, it's good enough. We type here 40 for the exact value, and here -5 for exact value. Okay, so it's good enough. Then we have changed, we set the front view, or you can say, okay, sorry, yes, front view. And so we need to change the downside a little bit. No, it's more than, so it's only -1, maybe it's enough. Maybe we have to write 0.8. No, I mean 0. Okay, 0.1 is, I mean 0.1 is okay. Just close and also select this duct. Okay, so here we can see our the basic model. We can decrease the span of the vertical stabilizer. Okay, so here I go in span and decrease the size of the vertical stabilizer. Okay, yeah, okay, it's good enough. We are going to apply the 7. Okay, no, it's very low, so 7.5 will be good enough. Okay, so here the outer body of the Airbus 320 is here. We are making with the use of the OpenVSP. So we are again see the all the things. So we first apply the fuselage, change the design, the length of the 37.57, and okay, we change the location of the wing to the 10 meter back, and in z axis apply the okay downward with the 0.5 meter only, and other thing is as it is not okay. And the span is 36.94 96. The code is 2.17, and the in section we change the first section. So here we can see the first section in the green boundary, green box is for its this green box the span is 17. Okay, this is, we are not considering the 0.5 and other things, and the root is 6.1, or you can say okay 6. You can take tip is a 0.9, swept angle is a 25, and the dihedral is a 1.5. And in section 2 we change our sweep span, so it's a 1.4. Okay, you take a 1.4, right? And the root chord is a 0.9 and tip chord is a 0.7. And the swept angle you need to take you can take 20 degree. Okay, we are not okay, and we apply the dihedral as a 41.35. Okay, we are not change any airfoil from, okay, but okay, so it's we are keep as it is the other airfoil section and the size, because we don't know the specific NACA number, and maybe they are not use the NACA series airfoil. Okay, and for horizontal stabilizer, we are just change our location to the 30 degree in x-axis, and on the z-axis we are use little bit down like minus 0.4. In the plane we change the span to the 15 meter. The area is, we take a chord is a 2.5, so it is change is related to chord. So, and we then change the, here not the any section, it's a whole of one complete section. So complete span is the same, 7.5. Root chord is a 4 and the tip chord is a 5 here. So basically it's a tip chord and here is a root chord. And we change the swept angle to 24, and okay. And here we little bit change the taper ratio to 0.15, and okay. Other things we keep remaining same. Then we add the vertical stabilizer. Here is the location. So in the x-axis we back to the 30 meter, and okay, here first we disable the symmetry with the uncheck of the exact plane, and rotate with around the x-axis to the 90 degree with the here. Then change the span to the 7.5, and the other things also keep remaining. Okay, then going to the section, the span is 7.5 because it's we are not separate the section here, it's a complete one section. And other thing is yes, so it's same as this. And we are not change also the airfoil for vertical stabilizer also. Then we apply the add the duct, and first we on the symmetry with the checkbox of the exact plane here, and then we only change the chord and the camber and the camber and the chord. Okay, we use the chord is a 5 meter and the camber is a 0.05, and okay, then we shaded. Now you can export this geometry in various section from here. Just click on the file, export geometry in this with the help of this type of format, the CAD format. You can also export in the OBJ format, and the STL format is also here, .stl and then .stp. So okay, and thank you for watching. I hope it's very helpful for you.